Have you ever looked up at the night sky and wondered about the stars and planets? The vast expanse above us, filled with countless twinkling lights, has always been a source of fascination and mystery. From the earliest civilizations to modern times, humans have gazed at the heavens, seeking to understand the secrets they hold. How do they move with such precision and grace? What invisible forces guide their paths across the sky? These questions have intrigued and puzzled humanity for millennia. Centuries ago, a brilliant mind named Johannes Kepler asked the same questions. Born in 1571 in the Holy Roman Empire, Kepler was a mathematician, astronomer, and astrologer who would go on to change the course of scientific history. He dared to challenge ancient wisdom and revolutionized our understanding of the cosmos. At a time when the geocentric model of the universe, which placed Earth at the center, was widely accepted, Kepler's ideas were nothing short of radical. Kepler was not content with simply observing the heavens. He was driven by a relentless curiosity and a desire to uncover the underlying principles that governed the motion of celestial bodies. He sought to unravel the hidden laws governing the motion of celestial objects. Kepler meticulously studied the works of his predecessors and contemporaries, including the detailed observations of the Danish astronomer Tycho Brahe. Imagine a detective of the cosmos, meticulously piecing together clues from the stars themselves. Kepler's approach was methodical and innovative, combining mathematical rigor with a deep sense of wonder. Through years of tireless observation and groundbreaking calculations, Kepler unveiled the elegant laws of planetary motion, forever changing our view of the universe. His three laws described the elliptical orbits of planets, the relationship between a planet's orbital period and its distance from the Sun, and the equal areas swept out by planets in equal times. His discoveries were nothing short of revolutionary. They provided a new framework for understanding the mechanics of our solar system and laid the groundwork for future astronomers, including Sir Isaac Newton, who would build upon Kepler's work to develop the theory of universal gravitation. Kepler's laws became the bedrock upon which modern astronomy stands. They are still taught in classrooms around the world and continue to be a fundamental part of our scientific heritage. Even today, centuries later, his work continues to inspire scientists and stargazers alike. The precision and beauty of his laws remind us of the incredible order and harmony that govern the universe. So buckle up as we journey through the life and discoveries of this remarkable man, a true giant upon whose shoulders we stand. Join us as we explore the legacy of Johannes Kepler, a cosmic revolutionary who dared to dream beyond the stars and forever changed our understanding of the universe. Johannes Kepler was born in 1571 in Weil der Stadt, Germany. It was a time of great intellectual and religious upheaval. The world was transitioning from the Middle Ages to the Renaissance, a period marked by a renewed interest in art, science, and philosophy. Kepler's childhood was far from idyllic. He was a sickly child from a poor family, and his father abandoned the family when Kepler was young. Despite these hardships, Kepler's sharp mind and insatiable curiosity shone through. He excelled in school, particularly in mathematics. He was drawn to astronomy from a young age, observing a comet with his mother and witnessing a lunar eclipse that left a lasting impression. These early experiences ignited within him a passion for understanding the heavens, a passion that would shape his life's work. Kepler's journey led him to the University of Tübingen, where he studied to become a theologian. However, his talents in mathematics and astronomy did not go unnoticed. He learned about the controversial heliocentric theory of Nicholas Copernicus, which placed the Sun, not the Earth, at the center of the solar system. This idea resonated deeply with Kepler. After completing his studies, he took a position as a mathematics teacher in Graz, Austria. But fate had other plans for him. He would soon cross paths with Tycho Brahe, a renowned astronomer who had amassed a treasure trove of incredibly precise astronomical observations. Brahe was impressed by Kepler's mathematical skills and hired him as his assistant. Their collaboration, though sometimes fraught with disagreements, proved to be a turning point in astronomy. Brahe entrusted Kepler with his invaluable data that would prove instrumental in Kepler's groundbreaking discoveries. Section 4. Breaking with the Past, the First Law of Planetary Motion. Armed with Tycho Brahe's meticulous observations, Kepler embarked on a quest to unravel the mysteries of planetary motion. Tycho Brahe, a Danish nobleman and astronomer, had spent decades observing the heavens with unparalleled precision. His detailed records of planetary positions were the most accurate of his time, providing a treasure trove of data for future astronomers. The prevailing belief at the time was that planets moved in perfect circles around the sun. This idea, known as the geocentric model, was rooted in the works of ancient Greek philosophers like Aristotle and Ptolemy. They envisioned the cosmos as a series of nested spheres, with Earth at the center and the planets, including the Sun and Moon, moving in circular orbits around it. This idea stemmed from ancient Greek philosophers and was deeply ingrained in astronomical thought. For centuries, this model was accepted without question, as it seemed to align with both philosophical ideals and the limited observational data available at the time. The notion of perfect circles was aesthetically pleasing and philosophically satisfying, reinforcing the belief in a harmonious and unchanging universe. But Kepler, with his relentless pursuit of truth, discovered something astonishing. He was not content with the established models and sought to understand the true nature of planetary motion. Kepler's dedication to his work was unwavering, and he meticulously analyzed Brahe's data, searching for patterns and inconsistencies that could reveal deeper truths about the cosmos. The planets did not move in perfect circles, but rather in ellipses, oval-shaped paths with the sun slightly off-center. This realization was groundbreaking. Kepler's analysis showed that the planets followed elliptical orbits, with the sun located at one of the two foci of the ellipse. This was a radical departure from the circular orbits that had been accepted for millennia. This was a radical departure from traditional astronomy and formed the basis of Kepler's first law of planetary motion. Kepler's first law states that the orbit of a planet is an ellipse with the sun at one of the two foci. This law fundamentally changed our understanding of the solar system and laid the groundwork for future astronomical discoveries. This discovery shattered centuries of astronomical dogma. The acceptance of elliptical orbits over circular ones marked a significant shift in scientific thought, challenging the long-held beliefs of the geocentric model and paving the way for a more accurate understanding of the universe. It was a testament to the power of observation, meticulous analysis, and the willingness to challenge established beliefs in the face of compelling evidence. Kepler's work demonstrated the importance of empirical data and the scientific method, showing that even the most deeply entrenched ideas could be overturned with careful observation and analysis. Kepler's first law paved the way for a new understanding of the solar system and the universe beyond. It set the stage for future astronomers like Isaac Newton, who would build on Kepler's work to develop the laws of motion and universal gravitation. Kepler's insights into planetary motion were a crucial step in the scientific revolution, transforming our view of the cosmos and our place within it. Section 5. Unlocking the secrets of speed, the second law. Kepler's pursuit of understanding didn't stop with the shape of planetary orbits. He was a man driven by curiosity and a relentless desire to uncover the mysteries of the cosmos. His work was not just about mapping the heavens, but about understanding the fundamental principles that governed the movement of celestial bodies. He delved deeper, seeking to comprehend the variations in a planet's speed as it traveled around the sun. This quest led him to analyze the vast amounts of data collected by his predecessor, Tycho Brahe, whose precise observations of planetary positions provided the foundation for Kepler's groundbreaking discoveries. Kepler observed that planets seemed to move faster when closer to the sun and slower when farther away. This observation was not just a casual note, but a critical insight that challenged the prevailing notions of uniform circular motion which had dominated astronomical thought for centuries. Through meticulous analysis of Brahe's data, Kepler discovered a beautiful and elegant relationship between a planet's speed and its distance from the sun. He spent countless hours poring over Brahe's detailed records, using his mathematical prowess to uncover patterns that had eluded others. He found that a line connecting a planet to the sun sweeps out equal areas in equal time intervals. This discovery, known as Kepler's second law of planetary motion, was a profound revelation that transformed our understanding of the solar system. This means that when a planet is closer to the sun, it covers a wider arc in its orbit, hence moving faster. Conversely, when it is farther from the sun, it moves more slowly, covering a narrower arc, This principle explained the varying speeds of planets in a way that was both simple and deeply insightful. This elegant principle, known as Kepler's second law of planetary motion, further refined our understanding of celestial mechanics. It was a testament to Kepler's genius and his ability to see beyond the surface, to uncover the hidden truths of the universe. It demonstrated that the motion of planets was not uniform but governed by a precise mathematical relationship. This was a radical departure from the idea of perfect circular orbits and constant speeds, showing that the universe operated according to complex and beautiful laws. This law provided further evidence that the universe was not random, but governed by underlying laws that could be deciphered through observation and reason. Kepler's work laid the groundwork for future astronomers and physicists, including Isaac Newton, who would build on these principles to develop the laws of motion and universal gravitation. Kepler's second law remains a cornerstone of our understanding of planetary motion, a shining example of how careful observation and mathematical analysis can unlock the secrets of the cosmos.